This video is about the basics of data munging or processing. Data munging or processing is required for basically every data set that you will have access to. Even when the data are nice and neatly formatted like you get from open data sources like data.gov, you'll frequently need to do things that make it slightly easier to analyze or make character names slightly better for use in modeling. So the goal is to get to tidy data, where each variable forms a column and each observation forms a row, and each table or file stores data about one kind of observation. So for example, the data about people are stored in one table, and the data about hospitals are stored in another table. So the other components, in addition to the three components of tidy data, are that we might want to have column names that are easy to use and informative, row names that are also easy to use and informative, and that we've removed obvious mistakes in the data, and we have variable values that are internally consistent. So a very common occurrence is if you have a character vector representing the sex of patients in a clinical study, you might have men labeled as both men and males, and we might want to consolidate that so that only male is used as the indicator of male sex. The appropriate transformation should be applied to variables as well so that they can be used in downstream analyses without having to transform the data over and over. This is typically done when you're analyzing a type of data set that you know that there's a particular transform that will be useful for you later on, either because you've seen it in exploratory analysis or it has been in the past. So this is a very partial list of data munging operations. So you might fix variable names, create new variables, merge data sets, reshape data sets, deal with missing data, take transformations of variables, check on and remove inconsistent values, and many more things. Honestly, this is just the very smallest part of data munging or processing. I'm going to try to illustrate the functions that are most useful for the greatest variety of data munging operations so that you'll be equipped to be able to process whatever data comes your way. Remember that the steps of data munging or processing should be recorded in their own script, R script, that's labeled so that you can tell where the processed data come from. Just to tell you the truth, 90% of the effort of data analysis is often spent on data munging. This is not where the glory is, but it is where the work is. And so to be able to analyze a data set very quickly and easily usually requires a ton of processing effort. But it's usually worth it because then you end up with data sets that you can easily share, distribute, and communicate to other people. So this lecture is going to focus on these first four components: fixing variable names, creating new variables, merging data sets, and reshaping data sets. The last three components will be covered in future lectures. So first we're going to talk about fixing character vectors. So in general, these commands that I'm going to be talking to you about can be used just as easily to deal with character vectors that are included as part of the data set, but I'll primarily be applying them to deal with the names of the data frame. And the reason why is because when you're doing your analysis, it's often easy to get confused if the names of the data frame are either inconsistent or have strange names that you're not used to or have weird capitalization and so forth. In that case, you might accidentally call the wrong variables or not be able to figure out what the right variable is to include in your model. So this is the camera's data that we downloaded previously from the fixed camera locations in Baltimore. And so I'm going to read that data in with read.csv and look at the names of that data set. So the names of the data set is just a character vector. And so each character string is listed here. There are actually 6 columns of the camera data. And so you can see that, for example, the first 3 elements of this vector are all entirely in lowercase, while the 4th vector or element of the vector has a capitalized letter. Similarly, the 6th element of the vector has a .1 at the end, which might be confusing later when you're looking for the location variable. So the first thing that you can do is use the toLower function applied to a character vector to make all of the letters lowercase for all of the elements of that vector. So for example, you see if we apply toLower to the names vector from the camera data, we see that, say, the cross street variable or element now no longer has a capitalized S in it. Similarly, the location element has now a lowercase l to lead with. You can also use string split to separate out components of elements of a character vector. So it's very good for automatically splitting up variable names that are confusing. If they have the most common occurrence is they might have dot followed by a number, and you might want to remove that dot number to make them a little bit easier to work with. So what you can do is use these string split command. And so what that is you apply string split to a vector of characters, and then what it returns is a list where in each element of the list, the character at that position in the vector has been split at the argument that you define by split. So it's best to see this with an example. So we have this names vector for the camera data, and so this is the names of the data frame. And you remember the last element was location.1, and the second to last element, the fifth element, was intersection without any dot. So if I apply a string split to this character vector, and I split it at the value of a period, then I will see what happens, what results. So when I want to split on a period, this is actually a special character used in R, and so we need to actually escape this special character. So we have to use this \\/ before the period, but this is just saying we would like to split every element of this character vector up whenever we see a period. So if we look at the fifth element, that was intersection, and there were no periods in that element. And so what we see is that intersection gets returned as the fifth element of this list, just as it was before with no splitting. However, the last element of the character vector was location.1. So if we look at the last element of the list that's returned, and we do this by to access an element of the list, we do this by using double brackets here. We see that the sixth element or the last element of that list actually returns a character vector itself, where this new character vector has location and 1, and the dot has been removed. So basically what it does is it goes through and it creates, anytime it sees a dot, it splits that character vector, that character element up into a character vector, where everything that came before the dot is the first element, everything that came after that dot is the second element, and the dot has been removed. So why is this useful? Well, we can use the sapply function to loop over all of the names of that data frame and remove the trailing dot, everything after the trailing dot for every element of that character vector. So recall that split names was the list that we got from the string split function, and so the sixth element was the sixth element of that list. And that list had, the sixth element of that list was a character vector that had location as the first element and 1 as the second element, and the dot had been removed. So if we select just the first element of that character vector, we can see that it's the location. And so what we would like to be able to do is loop over each of the names in the character vector and just select the first component of that list that results. So what we do is we define a little function called first element. And so all this function does is it takes a character or a numeric vector in and returns just the first element of that vector. So then what we can do is apply that function to every element of the list. And so what we do is we apply the sapply function to the split names. That was the list that came out of string split. And what we do is for each element of that list, we apply the first element function. And so what it does basically is it applies to that list this first element function and selects out only the first element of the character vector. So what you get as a result are a set of names that no longer includes the .1 at the end of location. This seems like sort of a convoluted way to remove just the .1 at the end of location, and in this data set it may not be necessary to go through such hoops. But in general, you might have lots of character names that you need to change all automatically, and so the sapply function allows you to do that very quickly. So now we're going to use the peer review data set again to explain a couple of other data munging operations that you might perform. So this is data on submissions and reviews of SAT questions. So each question gets answered by a particular person, and then that question gets randomly assigned to another person to review their answer and determine if it's correct or not. So again, to load in the peer review data, we actually have the URLs of the review and solution data sets that are on Dropbox. And we can download those files using the download.file commands that we've learned about earlier in getting data. And then what we can do is load in the reviews and solutions data sets separately with the read.csv command. So at the end of the day, we have two data sets, the reviews data sets and the solutions data sets. And what we would like to be able to do is look at those and see if there's anything that we need to do to process them, and maybe if we can put them together into one data set. So the first thing we do is we look at the top part of the reviews data set. We can use the head command and look at only the first two rows. And so we see that there are elements for ID, solution ID, reviewer ID, and so forth, and they all appear to be quantitative. Similarly, if we look at the top part of the solutions data set, we see similar sorts of variables, but now we see a problem ID and an ID and a subject ID and so forth. And here we think that maybe the answer variable is qualitative because it's reported here as a character. So one thing that we might want to do is, again, this is dealing with the names of the data sets, the data frames. So if you look at the names of the reviews data frames, we see that there is actually this underscore character in several of the names. So that might be useful, or it might be sort of inconvenience. In particular, if you're dealing with data sets where you have to match names across data sets, sometimes by having this underscore in one set of names and not in another, you'll cause names to not be able to match. So what we might want to be able to do is substitute out this character and replace it with something else. And so you can do that with this sub command. And so what you do is if you apply sub to this, the vector of reviews, names of the reviews, then what you can do is you can say take the character underscore and replace it with nothing in each element of this character vector of names of reviews. And so what you get instead of what you saw originally where you have underscores in several of the characters, you actually end up where that character has been deleted because we replaced it with no space at all. You could also replace it with a comma or a period or whatever else you want, and then you would end up between solution and ID with whatever character you had placed in here in the replacement value. So an important thing to keep in mind when you're using sub is that it only replaces the first instance of a particular character string that you want to replace. So this is a test here. This has nothing to do with the data set. So if we create a test name that has several underscores in it, and we apply the sub function to substitute the underscore with nothing in this variable test name, the first time that an underscore appears, it gets replaced, but everywhere else it does not get replaced. So instead of using the sub command, if you want to replace all underscores, you can use the gsub command. So the gsub command will again replace underscore with nothing in test name, but now it goes through and every time it sees an underscore, it gets replaced. So what you end up with is now a character vector that has no underscores in it. So another thing that you might want to do when you're doing data munging is actually take some quantitative variables and turn them into ranges. This is because sometimes you want to be able to look at variables at a glance, or sometimes you think that you don't necessarily believe the precision of the quantitative variables, so you want to look at just ranges of those quantitative variables. And to do that, you can use the cut function. So if we look at the reviews data set and look at the time left variable, it's a quantitative variable. And if we look at the first 10 elements, you actually see there's one missing value, but then these are the numbers of the time left for each of those reviews. And so what you can do is actually break that up into different ranges. And so what you do is you apply cut to the variable reviews time left, and what you can do is you tell it where you want it to cut that variable up. So here what we've done is we've passed it a sequence. So it's a sequence from 0 to 3600 by 600. So this sequence happens at 0, 600, 1200, 1800, 2400, 3000, and 3600. And so what you do is apply this cut function, and what you end up with is each element appears in between the two values that occurred in this list of cuts. So if we again look at the first 10 elements of this new cut up vector, what we see are, so the first element, 1754, is between 1200 and 1800, so it gets labeled as 1200 to 1800. The second element, 2306, appears between 1800 and 2400, so it gets labeled in the range 1800 to 2400. So basically we replace these quantitative variables with qualitative variables that are labels of the ranges where they appear. You can then look at the class of that ranges variable that we've created. It's now a factor variable instead of a quantitative variable. And we can actually make a table of those ranges. And so what this will do is now, instead of, if we had made a table of the actual quantitative variables, since they were quantitative, each value would essentially get would have been observed once. So you'd see a very long table with each element observed once. Instead, what we see is now the different ranges, 0 to 600, 600 to 1200, and so forth, and you get to see the number of times that there was a a value that was between 0 and 600, there were 30 of those times. 32 times the value was between 600 and 1200, and so forth. So it gives you a little bit of information if there are specific cutoffs that you want to look and see where the quantitative variables break down. You can actually do that with this cut variable or function. Alternatively, you can use cut2 if you want to break the values up by quantiles. So remember, when we used the cut function, we actually had to tell it where the breaks were going to occur. So it's 0, 600, and so forth. But if you use the cut2 function, you can actually pass it this parameter g and say equal to 6. And so what it's going to do then is break the data set up into 6 ranges, where in each range there's an approximately equal number of points. So what it basically does is break it up by the quantiles of this quantitative variable. So if we make a table of this new cut up variable, we see that there's about 20 instances in each of the different categories of this new cut up variable. So you might want to add this extra variable to your data set. So when you're doing data munging, sometimes you'll create a new data variable either by taking a transformation, or in this case by breaking a quantitative variable up into a qualitative variable that is defined by ranges. And sometimes you want to add that to your data frame. So what you can do is you define this time ranges variable by applying the cut2 function. And then what you can do is to add it to the reviews data frame, you just access the particular name that you are trying to load it into, in this case time ranges, and assign the value of the time ranges variable that we've created with cut2. So then if we look at the reviews data frame, we see that it now has one additional column, which is the time ranges variable. So basically what you can do is by using this $sign accessor, you can actually add variables to your data frame. Another thing that you might want to do is you might want to merge data sets together. So in the case of this data sets that we're looking at here, we have a bunch of solutions that were submitted by people, and we have a bunch of reviews that are the reviews of those solutions, and we might want to merge those two data sets together so that we can look at each particular solution and see who reviewed it and see what their response was and so forth. So the way that you merge data sets together in R is with the merge function. There are actually other functions that can be used to do this, and I'll explain a few of those, or refer to a few of those later, but this is the most common approach. And so what you can do is you can actually merge data sets together that have common variable names. And so what it's going to try to do is merge variables together based on their common ID, and then reorder the variables so that they're ordered by the common variable names. So the important parameters here are x and y, which are two data frames that you want merged together. By, which are the variable names that you want to use to merge the data sets. You can also break it up so that by x and by y, in other words, you can say you can match the variable names even if they're different across data sets and have them merged together. And then the all value, which says that you would actually like, even if there are certain values that don't appear in one data frame but they appear in the other, you would like an NA to appear in the merged data set. So just to show you an example of how this works, so we have the reviews data frame and the solutions data frame, and we're going to merge them together with the merge command. And we're not going to tell it at this point which IDs to merge on. So what it's going to do is it's going to go through and look at the reviews data frame and the solutions data frame and look at the names of those data frame. And if they have any of those names in common, it's going to try to merge those variables together. And we say all equals true because there may be values in solutions for a particular merging variable that don't exist in the reviews variable. So if we look at the merged data, what happens is we can see that now the solution ID and reviewer ID variables both exist in the same data set now because it's been merged. We see that now there's only one ID variable. This was a variable that was common to the two data sets. So this is the variable that they got merged on. And what you'll notice is that sometimes there are two values that cannot be reconciled. They both have ID 1, but they have different values of start and stop. So they end up creating two different records in this merged data set. And when the solution ID and reviewer ID don't exist for one of those records, they just get replaced with missing values. So it turns out when we wanted to merge the reviews and solutions data sets together, we didn't want to merge them on the basis of the ID, because if you go back and look, reviews actually had a solutions underscore ID variable. And so what we'd like to merge is the ID variable for the solutions to the solutions underscore ID variable for reviews. So what we do here then is use the by.x and by.y commands. So basically what we do is we say, okay, we're going to pass the data frame reviews and the data frame solutions to the merge command. And what we would like to do is merge them on the basis of, in the reviews data set, the solution underscore ID variable, and in the solutions data set, the ID variable. So basically what it's going to do is it's going to say, okay, I'm going to look for every time I see a particular solution ID in the reviews data set and see if I can find that same value of ID in the solutions data set and then merge those two values together. Again, I'm going to do all equals true, so if it can't find, say, a particular value of solution ID in the ID variable, it will just create a new row with NAs for the data set where it can't find those values. So here now I see that when I do this merging, I see that I get a solution ID and an ID variable and a reviewer ID. So what it's done now is this solution ID has replaced the ID variable for solutions, and it's merged these two data sets together. And so what you can see, for example, is the solution ID is 3 and the ID is 1 for this row or this record in the new data frame, this variable in the new data, or observation in the new data frame. And so if we go back to just the reviews data set, we can see that for the reviews data set, its ID was equal to 1 and its solution ID was equal to 3. And so this is that same record in the merge data set. And in the merge data set, we know that from the solutions data frame, we actually looked, this will correspond to the value of ID equal to 3. So it's actually merging two different variables together into one variable and then combining the two data sets on the basis of that variable. So merging is a little bit hard to explain here with these very simple examples. The best way to understand it is to practice. And so there'll be this week several practice examples where you can try out merge and see how it works. So another thing that you would like to maybe be able to do is to sort values. So in particular, you might want to see if once you put the values in order, how many of a particular value there are and so forth. And so the way that you do that is with the sort command. It has two parameters, x, which is the vector of values that you're going to sort, and decreasing, which is a parameter that tells you whether to sort them in decreasing or increasing order. By default, they sort them in increasing order. So if we look at the merge data reviewer ID in the first 10 elements, you can see that they're not in numerical order. So it goes 26, 29, which is larger, and then back to 27, which is a smaller value. If instead we sort the reviewer ID from this merged data set and look at the first 10 values, it's all 22, and that's because 22 is the smallest value of the reviewer variable, and it's in order from smallest to largest. So if you kept going and you looked at more elements of this, it would go all the 22 values, then all the 23 values, and so forth. Importantly, you notice that sometimes you have 22s is the same value for this variable, and so what it does is all the values that are 22 get sorted into a fixed order. When you want to sort a data frame by a particular variable, then you can use the order function. So the order function takes a list of variables to order, na.last parameter, which tells you where to put the NAs and whether to sort values into decreasing or increasing order, just like with the sort function. So let's see a little bit about how this works. So suppose we have this same reviewer ID vector and we look at the first 10 elements and we see that they're 26, 29, 27, and so forth. If we apply order to the same set of elements, the reviewer ID vector, and we look at the first 10 elements, they are 4, 6, 14, 22, 23, and so forth. So what is this order function doing? It's saying if I want to put these values in order, the first element has to be the fourth element of this vector. So I have to take 22 because it's the 1, 2, 3, fourth element of this vector, and make it the first value. Then it says the second value should be the sixth value of the vector. So it should go the 1, 2, 3, 4, 5, 6. So you see it's also a 22. So it needs to get moved into the second value and so forth. So basically what it does is it says how you need to rearrange these values in order to get them into order. And this is really useful because, first of all, you can reorder that single variable with this order command by saying, okay, I've got this vector of values, the reviewer ID values, and I want to sort them into order. So what I can do is take the indices that I get from the order command and just subset this reviewer ID variable or vector by that order. And so what it does is it will say, okay, I'm going to take the fourth value of this vector and put it first. Then I'm going to take the sixth value of this vector and put it second, and so forth. And so what it'll do is order the values for that particular vector. But what's even more useful is you might be able to reorder a data frame by a particular variable if you want to. So remember, we're looking at this merged data set, and if we look at just the first 6 columns in the first 3 rows, so this is selecting the first 6 columns here, and this is selecting the first 3 rows, what we can see is that this data set is not ordered by, say, the reviewer ID, and maybe we'd like to reorder the data frame so that reviewer ID is in order. So what we can do is actually take the merged data and then calculate that order function, which is, remember, this is the indices that are used to reorder the values so that they're in increasing order. And we can apply it now, we can pass those indices to the selection of the data frame and select the rows corresponding to ordering those reviewer ID vectors. And so what we get is then if we look at the sorted data that we generate by assigning that to sorted data, we actually see now that the reviewer ID is in order. So it's reordered all the other variables so that reviewer ID is in increasing order. And so it goes 22s followed by 23s and so forth. And it's reordered all the other variables so that it's still the corresponding values, the value corresponding to this reviewer ID is still the right value, they've just been reordered. The other thing that you can do is actually reorder by multiple variables. So in this case, each reviewer might have reviewed multiple solutions. And they might have a different ID for each of those reviews. And so suppose we want to sort both by the reviewer ID and put those in the increasing order, but we also want to sort by the ID of the individual so that the ID is also in increasing order. So within reviewer ID, we'd like the ID to be increasing, since each reviewer gets a certain number of reviews and they have a unique ID. So what we can do is then use this order function, but instead of passing order just the reviewer ID, we first pass it the reviewer ID, and then we pass it the ID variable. So what this does is it says, okay, give me back a set of indices that puts the reviewer IDs in order, because that's the first variable I passed to order. And then it says, okay, within each reviewer ID, let's go through and put the ID variable in order within that reviewer ID. And the reason why it does it within reviewer ID is because it's the second element that we passed is the ID variable, whereas the first element we passed is the reviewer ID. So then if we reorder our data set, or the rows of our data set, according to those indices, we actually can look at this data set and we end up with a data set that now has the reviewer ID in order, and then within each reviewer ID we have the ID variable in order. This can be useful both for just looking at your data set and for applying particular kinds of functions that require data to be in ordered values. So the other thing that we need to do, and was one of the components of tidy data, is that we need to maybe sometimes change the format of data sets. So basically this is changing the shape so that we end up with variables and rows, and so that we end up with observations in rows and variables in columns. So this is a misshaped data set. This is actually an example from this paper. So what it has is treatment A, treatment B, and people are the different elements of this data frame. And so then there are values that correspond to different treatments and different people. So what we want to do is reconstruct this data set into such a way that we have in each row we have a particular observation, and in each column we have a variable. And so one way that you can do that is with the melt function, which is in the reshape2 package. And so what you need to do is load the reshape2 package in, and then use these parameters to be able to reorganize your data set. So you need to have ID variables, measurement variables, and variable names. And so the ID variables tell you which IDs to, which of the variables is just an ID for a particular observation, and then which of the variables are actually measurements that we've taken for those IDs. And so we take this misshaped data set and we say, okay, the IDs for this data set are the people, and the variable name that we're going to name, the variable that we're going to collect is treatment, and then the value name is going to be value. And so what it does is it melts this data set. It basically takes the data set that was organized in such a way so that there wasn't necessarily one observation per row. You can actually see that here the treatment A and treatment B observations for John are both on the same row here. In the new data set, we have John for treatment A, and we get his value, and then we also have John for treatment B in a separate row and their value. So what we've done is basically put individual observations in individual rows and variables in columns so that the data are tidy. The reason why is that it's easier then to do downstream modeling with data that are in this format. Now there's obviously a lot more ways in which data could be formatted and a lot of ways in which it could be reformatted. So you can look at the Tidy Data and Tidy Tools presentation that I've linked to here that gives you a lot of information about that. You can also look into Andrew Jaffe's data cleaning lecture, which I've linked to here on Dropbox. Hadley Wickham talks about regular expressions which can be used for cleaning up variable names. And then in addition to the Reshape2 package and others that I've mentioned, a key component of doing data munging is just long, painful experience. I wish I could say that there was an easy way to take any data set, process it, and have it be clean automatically, but that's definitely not true. Each data set is messy in its own way, and so a lot of this is just practice and looking at different data sets and looking at the ways in which they're messed up and trying to figure out how to fix them. So I'll try to give you some examples of how to do that, but really the key to becoming a good data processor is practice, practice, practice.